Hello students, hope you're all fine now, and we are going to have a test on this topic of rotational motion. The theory portion already we have taken the test. Now we are going to have a test for the numerical part. The test is on Wednesday, so day after tomorrow. For you it could be tomorrow. So I'm just going to give a glance about what are the things that you have seen and how you are going to learn, plus a small topic which is left out. I will just do that also. So you can tick mark what are the example questions you are going to learn. So example number 1, yes, you need to learn this. We have already done this one. And then example number 2, yes, this also we have done. An automobile moves in this one, so it is just a value. And then you already done this one also. It is all based on the equations of motion, equations of rotational motion. This also we have done. And we have example number 4. 3 and 4 are quite similar. And also example number 5. So example number 5 is also it deals with the equations of motion here, rotational motion. Example number 6 we did not do. You can just cross this one. You need not do this one. Example number 7 also we did not do this one. You can cross this. We need not do this. Example number 8 also we need not do this one. It is just a representation of the vector product, so you need not do this one. And also example number 9 also you can cross this one. We need not do this, right? So you have 7, 8 and 9. So all this 6, 7, 8 and 9, all of them they need not do. Question number 10, yes, we have done. It's a very simple question. Even if you have not done, you can just take a look on it. It's quite simple. It is just a product of torque and angular velocity. That is the power of the motor. The next one is question number 11. We have not done this one, but you have to do this one yourself. Please try this one. It is just two vector products, F and R, and you need to find the torque. R cross F is the value. So it is just a product of cross product. So you will get an answer here. Question number 12 also you have to do it yourself. We have not done it in the class, but you can do it yourself. The ratio of angular momentum, it is given here. And the area enclosed in the orbit also it is given there. You need to find out the area enclosed. So it's a very simple question which talks about the pi r square, the entire area we need to find out. So once you have found out this angular momentum and as well as the frequent angular velocity 2 pi r upon t, then you will be able to make it. Okay, so you can just take a look on this. Question number 13. We are not going to do this one. You can cross this one saying that we need not do it. I hope you are able to get an idea about what to learn, what not to learn from the example questions. The next one is question number 14 and question number 15. These all things are we have already finished. 14th is something to do with the moment of inertia. This you can take a look on this one. Even if you have not done it, you can just take a look. It's very simple, just to word this one. 15th, yes, we have done it. Tick mark. We have done this one before itself. You found the ratio of the angular acceleration. Question number 16 also we have done this one. It is also dealing with the angular momentum values. And question number 17 also we have done. So it is dealing with the ratio of kinetic energy of rotation. Question number 18 also we have finished. We have done this one. Please tick mark that also. Question number 19 is a very long question. We have done this one. It deals with a sphere which is rolling down an inclined plane. It's a long question. We have done this one. Quite interesting. Important too. Please make sure you learn this one thoroughly also. And question number 20 also we have done this one before. So please take a look on this. Question number 21 also we have done this one. So it is also a nice question, simple question. And question number 22 also we have finished. We have done this one, question number 22. So this entire part it is all quite together. It has the same kind of an energy conservation, so you can have a look on this also. This is also, we have done this one. And the next one is question number 23. A man is standing on the rotating platform. This also, we have done this one, so you can take a look on this. And question number 24, we have not done this one. You can cancel this one because it deals with a variety of center of mass and many things, so I've just cancelled this one, so you need not do that. Question number 25, we have done this. This is a nice question. We have done this one, so you can take a look on this. So finally, this is the answer you will get. So now question number 26, 27, 28. I have not done this one, but right now I'm going to do it. So you can just tick mark 26, 27, 28. You have to do this, right? And question number 29. Also, we have done this one already. We have finished question number 29 earlier. We have finished this one. And question number 30 also, we have done this one earlier. Okay, which talks about the ratio of the angular velocity we need to find out. And question number 30 also, it's a simple question, quite a small one, so you can tick mark this also. We have done it. So question number 32 also, we have done it. So when the earth shrinks to half of the present size, then the timing will be 6 hours. Question number 33, tick mark. I will do it right now. Okay, there are 4 questions. I will do it. This also I will do it. Okay. Question number 34 here. This you can cross it. We have not done this one. It's okay even if you don't do this. It is same kind of an laws of motion question, finding tension and other things. So I just left it. Question number 35 also, you can just cross it. We need not do this one. And same goes with question number 36. You can don't cross mark this. You can just do it yourself, because it is same kind of a moment of force which you have done in the 10th standard class when you were in small class. Okay, so please take a look on this. It is a very simple question, so don't cross this one. Just you can tick mark. Question number 37, again cross mark. Don't do this one. We have not done it. It is something which is doing with a couple and other things only, but it's okay. We did not do this one. Question number 38 also, you can cross this one. It deals with a body which is rotating and moving along, and the various center of masses, right? And question number 39, again you can cross mark this one. We have not done this one, so it is a question which has quite a lot of components. Then question number 40, yes, we have done this one. Please make sure you do this one again. It is pretty important. We have done this question. Okay. Then the last one that I have done, that last part is the last 3 questions is all we have done this one. So 41 we have done, 42 we have done this, 43 also we have done this one. Okay. With this the example question gets over. All the 43 example questions, there are around 10 to 12 questions we have not done this. So rest of them we have done it. So around 30 questions we've finished, but around 12 to 13 maybe some of them, that much number we didn't do it. I've already asked you to do the example questions, sorry, the exercise questions, the exercise numericals right from this one. So numericals based on torque, equation of motion, and then this one 7 questions you have done it, and then the rest of them also 8, 9, and this entire questions right till 25, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, and then it goes on to finish from 19 to 25. If you have any doubts in these questions, please drop a message to me. If there are any number of questions that you don't understand, then I could just put a quick video on that. Maybe tomorrow I can try to do that. Once you're seeing this video, you find any questions which you have not been able to solve in the exercise questions, please drop a WhatsApp message. I'll be able to solve it and make a short video for that and then send. Now we are going to do the 4 questions which I said that I'll be just doing right now. So those questions are question number 26. turn to page number question number 26. Right? 3 mass point M1, M2, M3 are located at the vertices of the equilateral triangle of length A. What is the moment of inertia of the system about an axis through the altitude of the triangle passing through the through M1? So we are having a diagram like this. Same diagram. I don't want to mess up that diagram, so I will just draw another one here. Okay. So 3 of them. So there is a 3-body system. That is A. So A, B and C. Okay, this is also A. Thing is, you have made an axis along this one and it is revolving. So all of them are mass M1, this is M2 and this is M3. We need to find out the moment of inertia of this whole thing passing through this particular axis when it is rotating like this. So at this point of time, M2 is going along this one with a distance of A by 2. M3 is also going along with this distance of A by 2 from the axis. So what is the moment of inertia now? Mi is going to be equal to, it is going to be M1 M1 A square plus M2 R2 square plus M3 R3 square. This is the value. 3 masses M1, M2, M3, R1 square plus R2 square plus R3 square. Now what is this R1? What is this R2? What is this R3? We need to substitute. M1 into 0 because M1 is right there on the axis itself. Okay. Plus M2 into A by 2 the whole square plus M3 into A by 2 the whole square. So we have to just take things outside. M2 plus M3 A square by 4. That is moment of inertia. So you have this 2 masses and then A to A square by 4. So that's it. Quite simple. These two, this is going around this A by 2 as an axis. This is also going around in A by 2. So we are just going to take R1, R2 and R3. The distance from the axis of rotation. This is just on the axis of rotation, so the no distance is there. That's all. Okay. So the next question. Question number 27. This is question number 26. Question number 27. A symmetrical lamina of mass M consists of a square shape with a semicircular section over each edges of the square as shown in the figure. So this is the figure which is pretty nice. This is 2A is the side of this one and then it goes around this one. So what is this distance? This is going to be A. What is this distance? This is also A. Okay. So from here to the edge it is 2A. If this is 2A means from the middle to the end is 2A. From here to here is 2A. From here to here is also 2A. So this distance is also 2A. And here also it's 2A. So please make that understanding clear. The sides of the square is 2A. The moment of inertia of the lamina about an axis to the center of mass and perpendicular to the plane is 1.6 ma square. So it is I center of mass is going to be equal to 1.6 ma square. That means if you put a straight axis going through the straight and then going down, then it is this value. This is given here, right? So if I try to draw this particular thing, right? So this is 2A and this is also 2A. This is also 2A, right? And I have an axis here. So straight down from the top to this one, straight down, if you just make an axis here like this, Okay, it just makes an axis standing like this. So from this one, okay. So that means what happens? It is just going rotating like this. This is the value. Now if that is the value here, what will be this particular thing? If you want to rotate in this axis here, if you want to rotate in this axis here, like this, okay, you can see what is going to be the value here. At the end of the time, we need to find out the axis of AB. If it rotates in this axis, what is the value? We need to find out. That's what is given here. Tell the moment of inertia about AB. About AB is the line you need to find out. About AB. So I will just make this line a little more thick. This axis you need to find out. So what is the distance from the center? This is 2a is the distance. Right? But before finding AB, what we need to do is, we know only this center point. From this one, you find out what is the value of the moment of inertia of this axis. Okay, how to do that one? It is using perpendicular axis theorem. What is the perpendicular axis theorem? It is Ix is going to be equal to Iy plus Iz. So here Ix, this one Iy, maybe you can say Iz is this one, and this is Iy is this one, Iy and Iz, these two things, and the center point. Center point is the one, this is one it's given here. Ix is given here as 1.6 ma square is equal to Iy plus Iz. This Iy is equal to Iz. Iy, it should be equal to Iz because every parameter is same. If you look at this distance, everything is same. So it's going to be 2 times of Iy, or maybe 2 times of Iz. Let us take Iz. That is 1.6 ma square. So what is Iz then? What is Iz? This is Iz. What is the value along the Iz? So this goes down. This is 0.8 ma square. This is Iz square. We have got it. Iz is equal to 0.8 ma square. Then what is this one then? You can apply the parallel axis theorem. Okay, along AB or mi along AB using parallel axis theorem. So how do you use parallel axis theorem? First of all, this one, moment of inertia along the center of mass plus mass into the distance square. Distance is 2a square. From the axis of rotation, this axis is 2a distance. This is 2a distance. So what is the mass of this one? So moment of inertia along AB. So I along AB is going to be equal to, what is I center of mass? So moment of inertia along center of mass is this value, 0.8 ma square plus m, it is 4 ma square. So this is the value. With this it goes over, right? If you want to add this one, it is going to be 4.8 ma square will be the answer. Pretty simple. Using one thing, you found the perpendicular using this particular thing along the same side, along the side we found out, and after that, using that, we found out the another one in the last part. Okay. Going to the next question, question number 28. This question is a very little tricky question, but it is pretty easy question also. Point M1 and M2 are placed at the ends of the rigid rod. So there is a rod like this. So it is placed here. M1 is placed here. M2 is placed here. Okay, of L is the negligible length of this one. So the rod is set rotating about an axis perpendicular to this length. Locate a point on the rod through which the axis rotation takes place should pass in order that the work required to set the rod rotating with the angular velocity is minimum. maybe you can locate any point where this should rotate, right? So if that is the way in which it is to be rotated, we need to locate a point. Maybe it could be in the center also. It's up to you. It could be in the center also, but locate a point where the angular velocity is minimum. Okay, angular velocity is minimum. When you say angular velocity is minimum, what do we say that? How do we say that? So we need to understand that. If angular velocity should be minimum, that means let us take the work done principle. Work done is going to be equal to half I omega square. You know this formula here. Now, when angular velocity is minimum, if this is minimum here, when this goes down very less, right, then what should be the value of the work done then? Alright, the work done, the dw by dt should be equal to 0. The rate of change of work done should be equal to 0 because angular momentum velocity is going to be minimum here. So this is the condition. The condition is the work done is going to be equal to half I omega square, but the rate of change of work done, this is work done, dw by dt should be equal to 0. Then we will be able to see the minimum work done. So this is the condition. Let us see how it goes. The way in which we are going to see is, consider x is the distance here, and what is the distance here? This is going to be equal to L minus x. So moment of inertia is going to be equal to m1 r1 square plus m2 r2 square. We know this one already. So m1 into x square plus m2 into L minus x the whole square. That is moment of inertia. Right? So this one you can leave it here itself. This is moment of inertia. The next one is kinetic energy of rotation. Is going to be equal to half into I omega square, which is going to be equal to half into, this is I value, m1 x square plus m2 L minus x the whole square into omega square. I is given here. This is the I value, just dropped here. That is going to be equal to kinetic energy of rotation. That's also equal to work done. Okay, that's also equal to work done. So for minimum angular velocity, the dw by dt should be equal to 0. So what happens here? This entire thing, dw by dt means in this entire thing you will find, so all of them should become 0. Now try to differentiate this one. Okay, try to differentiate this whole value here. So as you differentiate this whole value here, you will be able to find out here as sorry, it is not dw by dt, it is dw by dx, the rate of change of work done with respect to the distance. What is the distance it will be? So when you differentiate this one, okay, when you differentiate this one, it becomes here as m1 is here, x square you differentiate, it will become 2x, so it will be 2x plus m2 you put here, the square it goes to the level x, alright, and then this is minus x has to be differentiated, it will become minus 1, that will become equal to 0. So it becomes 2m1x minus 2m2l minus x is going to be equal to 0. It is the rate of change of work done with respect to the distance. So every distance as it goes, in this particular point, the rate of change of work done, the dw by dx should be equal to minimum. Minimum means it is going to be equal to 0. So this entire thing is differentiated with respect to x. So when you differentiate this with respect to x, half will become 0 here. So only this one will take place. 2x will become, this also 2 into L minus x will become, and this also when it cross multiplies to 0 it will become 0. So we are not considering the omega square here. So this whole value m1x is going to be equal to 2m2l minus x. It gets cancelled out. So what it is then? Now it is m1 to x is going to be equal to m2l minus m2x. So take this to the next side. m1x plus m2x is going to be equal to m2l. So x is going to be equal to m2l upon m1 plus m2. Because this you can take common outside, this will be the answer. Okay. The x distance should be, how far it should be, it depends upon the masses. If the mass are equal, this m is equal and this is equal, then it will become the center. You already know this one. If m and this is also m and this is also m, then it will become L by 2. Right? So this whole thing will become L by 2. But we don't know about mass. This could be bigger mass, this could be smaller mass. At what distance it could be minimum. This is the formula which phases. It depends upon the masses and the length. Hope you're able to understand this one. Please make sure this also you try to correct this one. dw by dx should be equal to 0. Okay. Last question. This is question number 33. Question number 33. Please take a look. In figure is shown a disk of mass m and radius. Its center is at x-axis at a distance of a from the origin O in xy plane. Calculate the moment of inertia about x-axis, y-axis and z-axis. This is a diagram which is given here. Okay. Now if that's a diagram here, how to start with? I'll just redraw this diagram here. So this is going to be the circle. Okay, and this is going to be the radius r, and this part is at a distance of a from the center, and this is y-axis and this is x-axis. And what is the z-axis here? It will be z-axis will be here. This is z-axis, right? So that is z-axis here. So first thing is, when it rotates in the same axis along x-axis, that means it is rotating like this. It's just rotating within the same thing. It is rotating like this. That is what x-axis. Moment of inertia along, this is a part of it, along x-axis. So this disk, no, it is a disk here. So we already know disk, when it goes in the center, it's going to be equal to half mr square. So what is the thing when the disk is rotating along this direction, in this one? It's going to be equal to the moment of inertia along x-axis is going to be equal to 1 by 4 mr square, because we know this is half mr square, and this will be again, it will become another reduced to half, because you know we need to do two things: perpendicular axis theorem along z-axis and along y-axis, and then you need to put this value, so it will become 1 by 4 mr square. If you don't understand this one, please go back and refer the disk one, what we have done along the axis passing through the disk. We have done this one. Okay, same thing we have done. So that's the same thing which is there. Okay, so when it is rotating like this. The next one is along y-axis. Along y-axis means, how does it go? Then this particular thing, it starts moving like this. It starts moving in this direction along y-axis. So the same thing, it just goes like a fan. It just goes, rotates, and then comes back, and then comes back here, and this does so. Okay, so we need to find out how it is. Now if this is the case there, now we have right now this particular thing we have found out. This is also the same, this is also the same. What is this one? 1 by 4 mr square we just found out. This is the one along the same flat thing along the diameter, it will be 1 by 4 mr square. Just now we have found out this. So when it goes along the same direction here like this, so it becomes this axis, parallel axis theorem. B part of it, mi along y-axis. Using parallel axis theorem. Using parallel axis theorem. So I is going to be equal to I center of mass plus ma square. This is the formula. What is I center of mass? Along the center, what is that one? It is going to be equal to 1 by 4 mr square. And then this entire mass is at a distance of a distance. This is at the distance of a distance. So it's going to be ma square. So that's the value here. So what is that? Is it same? Yes, this is the final answer. 1 by 4 mr square plus 1 by 4. If you wanted to just take it something here and there, you can do that also. M, you can take it common outside. R square by 4 plus a square, you can also put this one. That is I. Then C part of it. C part of it is, what happens if this one makes this circle? It just goes along the z-axis. Along the z-axis, it goes from here and comes down. Hope you're able to understand this part of it. This is going to be in kind of like this along the y-axis. Now z-axis means it just goes up, 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 and then comes down, and again comes straight down, and then again goes up like this. Are you able to see that one? It just goes up and comes down. So that's the way it is, because it is going on the z-axis part of it. Then what happens here is, you need to take, how it is easy to take, what kind of thing, you need to take the axis which is passing through the center. Okay, so what is the axis passing through the center here? Perpendicular to the center. So that is mr square by 2. So this is moment of inertia along z-axis. So using the mi passing perpendicular to disk. What is the moment of inertia passing perpendicular to disk? I center of mass is going to be equal to half mr square. We already know this one. In a disk, when anything passes through the center, it is half mr square. So the same thing, half mr square is going to be the thing which it goes through the center and goes away. This axis could be anywhere because it is a kind of flat plane like this. So this axis is parallel to this axis. And what is the distance here? This also will be a only. So you get here in this pattern. Therefore, moment of inertia along y-axis is going to be equal to I center of mass plus ma square. This is the usual formula. Half mr square plus ma square. M, take it common outside. R square by 2 plus a square. This is Iy. Alright, this is done. This question is done. This question is done. And the first part is, this is the value. So, moment of inertia along x-axis, moment of inertia along y-axis, sorry, z, this is y-axis, is y-axis. This is moment of inertia along z-axis, please. The last part is moment of inertia along z-axis, this value. So, x, y, z, all things are done here with explanation. Alright children, with this I close. Hope you will have a good understanding and try to do the numericals. Practice well. See you when you are doing the test. Thank you.